So as you can see the block diagram here, the block diagram represents a cascade control. You can see that I have used only two controllers, GC1 and GC2. Definitely there can be more than two controllers. And also two controllers, GC1, GC2, there are two loops. The outer loop, the bigger loop is called the primary loop, the master loop, and the inner loop is called the secondary loop. I told you that while tuning, what we have to do, that while tuning we have to first tune the secondary controller, the slave controller, and according to that we have to tune the primary controller. When you are solving this block diagram, while solving the block diagram also, you have to first solve the inner loop and then solve the outer loop. And the solution of the block diagram is exactly same. I am also showing here the solution. The solution is completely same, exactly same as a normal standard feedback. क्योंकि ये भी feedback loop ही है, मैंने आपको बताया. The method of solving this cascade block diagram is same as the method of solving the feedback control loop. Okay, you can see here that I have shown here two loads and two process, GP1 and GP2. Right? So one is primary process, one is secondary process. You can compare this diagram with the physical process also. Right, where we are taking only two measurements. In that case, we can compare this process. So this is how we represent the block diagram of cascade control. So I hope everything about cascade control is now clear, that why cascading is done and how cascading is done, what is cascade and how it is different from the feedback control, this conventional feedback control. The second strategy for the advanced control strategy, the second one is called the feed forward control strategy. Put the heading feed forward control strategy. So again, like the previous one, we are going to write few points. Write down feed forward control strategy. Okay. Now, how it is different from feedback, that we have to mention here. So write down that in feedback control strategy, again we'll write down the points only. In feedback control strategy, the effect of disturbance is felt, and after that only corrective action is taken place. Corrective action is taken. Okay, after that only corrective action is taken. Right? This was the nature of the feedback control कि पहले नुकसान होगा फिर भरपाई होगी. मैं शुरू से ही बोल रहा हूं, ठीक है. Even in cascade, this was the case. In cascade is exactly like feedback. The only thing is there was multiple measurements, there were multiple controllers, there were multiple loops. Right? Okay, so only then, after that only, we have to take the corrective action. Right? After that only corrective action is taken. While, what is the logic behind, okay, I'll write that as a separate point. So, feedback control strategy or feedback control is also called compensatory control strategy. Because it is acting as a compensation. Compensatory control strategy. Okay. Now you know that we generally hear this line, there's a saying that prevention is always better than cure. You should be always, if you are already prepared for some kind of difficulty, some kind of problem to which is about to come, you know that yahan kuch aisa hone wala hai. If you are already prepared, then definitely your steady state won't be much disturbed, right? So in real life also, it is suggested, it is good to become anticipatory. If you are anticipatory, you are ready for the upcoming disturbances, you are ready for the upcoming problems. Can be a natural disaster. Suppose in that case you were informed before the natural disaster by there are various mediums through which you can know that okay, something is going to happen. This is true in the case of cyclones, in the case of tsunami, in the case of flood also sometimes this is true. So agar aap pehle se tayar rahenge, then prevention is always better. Of course, cure is something, cure is similar to feedback control. क्योर आप नुकसान होने के बाद अपना इलाज करा रहे हो, दैट इज फीडबैक कंट्रोल. बट इफ यू आर टेकिंग प्रिवेंटिव मेजर्स, लाइक अगर आप कोरोना का एग्जांपल ले लो, वी आर एवरी टाइम वी आर सेइंग दैट वॉश योर हैंड्स, वियर मास्क, वियर ग्लव्स, don't go much in public, don't interact with public, don't shake hands. What are these things? These are cures? No, these are preventions. Cure is something else. You'll be provided with the basic medicines. It will be provided. आपके साथ hit and try किया जाएगा, जो भी होगा आपको ऑक्सीजन सिलेंडर की जरूरत पड़ेगी. That is cure. That is feedback control. But if you are taking preventive measures, then it is always good for you. So theoretically speaking, what is the logic behind feed forward control strategy? That feed forward control is a kind of preventive control. You anticipate the things and take preventions ताकि आने वाली चीजें आपको कम नुकसान पहुंचाएं. Right? This is the logic behind feed forward. That you are going to take precautions, you are going to take preventions. Right? That is the logic. So what is the difference? The major difference between feedback and feed forward, that in case of feed forward control strategy, corrective action is taken before the impact of disturbance is felt by the system. Before the impact of disturbance is felt by the system. Okay, impact of disturbance is felt by the system. So that is the main difference. The first major difference here between feedback and feed forward कि feedback में आपका impact होने के बाद आप उसकी इलाज करते हो, और feed forward में you are already taking the preventive measures. So in a sense you can say that feed forward acts in an anticipatory manner. Feed forward is going to anticipate मतलब आप पहले से predict कर सकते हो. You can predict. Now I'll come to that point. Feed forward control strategy acts in an anticipatory manner. This one compensatory, this is anticipatory. अब कई बच्चे यहाँ बोलते हैं सर आपने तो बताया था कि that a derivative controller is anticipatory. Yes, but that is controller, this is control strategy. This strategy is anticipatory, that controller is anticipatory. That was a feedback controller, a type of feedback controller which predicts the error. So that derivative controller, we can say that the derivative controller is anticipatory, right? However, if you talk about control strategy, the feedback control strategy is not anticipatory, right? So feed forward control strategy is anticipatory in nature. Strategy is anticipatory. I'm writing in capitals, please note down, anticipatory. Okay, in nature. Now the problem is that I told you that you can't predict that when disturbance will come. In real life, being anticipatory is always good. In real life, being anticipatory, you are always prepared for the problems which may come. राइट आप पहले से ही तैयारी करके रखते हो. भाई बहुत सीधी सी बात है, सर्दियां आने वाली आपने पहले से ही जाके परचेजिंग कर ली, गर्मियां आने वाली आपने उससे पहले, आप यही करते हो ना. यू नो दैट समर इज गोइंग टू अराइव. आपने एसी सर्विस करा लिया, ये आपने कूलर सर्विस करा लिया, आपने दूसरी चीजें जो भी आपने खाने पीने की चीजें घर पे रख ली, आपको पता है कि भाई ऐसा ऐसा होने वाला है, राइट. सिमिलरली इन केस ऑफ विंटर्स यू मेड द अरेंजमेंट्स. ओके, बारिश होने वाली, आप बाहर जा रहे, यू आर गोइंग फॉर सम वर्क, यू नो दैट द वेदर इज, इट सीम्स लाइक इट विल बी रेनिंग, सो यू आर गोइंग टू टेक प्रिकॉशंस. सो इन रियल लाइफ बीइंग एंटिसिपेटरी इज वेरी गुड, and it is always appreciated that you should be anticipatory in real life, not compensatory. So the same logic applies in process control also. In process control also, the control strategy, which control strategy is better? Of course, there is no single answer for this, but yes, theoretically speaking, anticipatory control strategy is always better. But again, there is a problem. This is not the final answer. Listen to me carefully. Anticipatory control strategy is always better because obviously ना यहाँ पे देखो यहाँ नुकसान नहीं होगा. You are taking corrective action before the impact of disturbance felt by the system. So of course your system won't deviate. So of course this is good. But the thing is, can you anticipate the error? No, you can't anticipate it. Error may come, error may not come, right? You can't do that. But what we can do here, so there, here in this strategy, in feed forward strategy, इसको एक अलग points में लिख लेते हैं, fourth point में. What we do here basically, that is one more major difference between feed forward and feedback. In feed forward strategy, in feed forward strategy, disturbance is measured. Disturbance is measured. That is very, very important. Write down. Disturbance is measured and not the controlled variable. Disturbance is measured and not the controlled variable. Okay, controlled variable. That is one major difference between feed forward and feedback. Feedback में क्या बताया था आपको? In the feedback, you measure that variable which is we are controlling. Means the measured variable is same as the controlled variable. While in feed forward, the measured variable is not same as controlled variable. तो हम disturbance को measure करते हैं. We measure disturbance here in feed forward, right? And according to that measurement, the controller anticipates that what impact it will be having on the control variable, और उसको पहले से ही वो सेट करके तैयार कर देता है कि अल्टीमेटली इसका इंपैक्ट क्या हो जाए, कैंसिल हो जाए, नेट इंपैक्ट विल बी जीरो. You know, suppose increase in temperature is going to take place, the controller will anticipate, it will do the calculations, right? So in feed forward strategy, disturbance is measured and not the controlled variable. Fifth point, when there is a change in disturbance or a change in load, the controller is going to anticipate. ये anticipation है. Controller ये anticipate नहीं करेगा कि error कब आएगा या कितना आएगा. Controller can't anticipate कि error कितना आएगा. आप क्या error anticipate कर सकते हो? नहीं. Error may come, error may not come. There can be any magnitude, any sign, any type of error. But what the controller is going to anticipate is the calculations. When there is a change in load, or it may be the set point also. When there is a change in load, the controller is going to anticipate that what impact it will be having. Anticipate that what impact it will be having. भाई ये डिस्टर्बेंस में जो चेंज हुआ वो प्रोसेस को कितना असर करेगा, और उतना ही ऑपोजिट डायरेक्शन में उतना ही एक और एक्शन कंट्रोलर ले लेगा. सपोज अगर आपको कंट्रोलर को पता लग गया कि टेम्परेचर बढ़ने से इनलेट, सपोज कंट्रोलर इज मेजरिंग द इनलेट टेम्परेचर, राइट? Because inlet temperature is the disturbance. Now inlet temperature increased. So controller calculated that this much increase in the inlet temperature is causing this much increase, will cause this much increase in the temperature. Now, before the effect of disturbance is felt by the system, the controller will automatically open the cooling water valve. And that opening of the cooling water and the impact of the inlet, they will cancel each other and the system steady state will be maintained. मतलब सिस्टम को फील ही नहीं होगा, कि कुछ हुआ है ना, कुछ ऐसा लगेगा कि नहीं कुछ नहीं हुआ, बिकॉज डिस्टर्बेंस ने कोशिश की चेंज करने की स्टडी स्टेट, बट देन द कंट्रोलर ऑलरेडी नो दैट दिस मच चेंज इन द डिस्टर्बेंस कैन कॉज दिस मच वेरिएशन इन द स्टडी स्टेट ऑफ द कंट्रोल्ड वेरिएबल, सो आई शुड ओपन दिस मच ऑफ वॉल्व and then everything is perfect. Okay, this is called feed forward control. So when when there is a change in load, the controller is going to anticipate that what impact it will be having on the control. ये थ्योरी है भाई, देखो इसमें ज्यादा कुछ नहीं करना है, ऐसा नहीं सोचो सर क्या करा रहे हो, थ्योरी है इसमें, बस लिखते चलो. हैविंग ऑन द कंट्रोल्ड वेरिएबल, राइट? कंट्रोल्ड वेरिएबल ये एंटिसिपेट करता है कंट्रोलर. एंड यू मे आस्क सर कंट्रोलर को कैसे पता लगेगा? कंट्रोलर हैज ऑल दी अगेन मटेरियल बैलेंस, एनर्जी बैलेंस इन द फॉर्म ऑफ कंट्रोल एल्गोरिदम. भाई कंट्रोलर आपको पता है ना, कंट्रोलर क्या होता है? कंट्रोलर इज अ कोड, कंट्रोलर इज अ प्रोग्राम इन द फॉर्म ऑफ एल्गोरिदम. वी फीड दीज बैलेंस इक्वेशन इन द कंट्रोलर, राइट? एल्गोरिदम के फॉर्म में सारी चीजें हम कंट्रोलर में डाल दें, कंट्रोलर कैन कैलकुलेट, right? Okay, so anticipate that what impact it will be having on the control variable, and it takes corrective action beforehand. It takes corrective action beforehand. What is the meaning of beforehand? Beforehand means when the process did not feel any impact of the change in disturbance. Before the process can feel any impact, before that only आपने पहले से ही कर दिया. होता है ना, आप रियल लाइफ में ऐसा बहुत कुछ करते हो, आपको लगता है ये ऐसे होने वाला है, ठीक है, सपोज कुछ ऐसा चेंज आने वाले, कई सारी ऐसी चीजें रियल लाइफ में, आप न जाने कितने एग्जांपल्स हैं. यू फील लाइक ओके दिस प्रॉब्लम इज गोइंग टू अराइव somehow from your experience because you have algorithm in your mind. You know that in these kind of situation this problem may arise, right? आप ऐसा करते हो, आप पहले से प्रिकॉशन ले लेते हो ताकि आपके साथ जो लोग हैं उनको फील ही ना हो कि कुछ हुआ, right? So this totally depends upon how experienced you are, right? This totally depends upon how experienced you are. Fine. बहुत सारे न जाने कितने examples होते हैं. Once we were going for a trek in Himalayas in, I think it was the season of March or April. In March or April, we were going for a small mountaineering session. There is a place in Himalaya called, in Uttarakhand it is called Chandrashila. Chandrashila trek was there, right? And in the month of April, we were 5-6 guys, okay? So one of us did the trek before also. So he knew that the snow is very slippery. Actually, snow ke saath kya funda? If it is fresh snow, then it is difficult to walk because the fresh snow is not, you will not be able to walk easily on the snow. आप पैर रखोगे, your foot will go down into the snow, deep into the snow for 1 feet or 2 feet if it is fresh snow. और अगर snow hard है, again it is difficult to walk because it is slippery, right? In that case, your normal sports shoes, अगर आप sports shoes पहन के snow पे, hard snow पे ट्रैक कर रहे हो, आप slip कर जाओगे. और hard snow पे slip करने का पता है प्रॉब्लम क्या होता है? उस समय तो कुछ पता नहीं लगता, जब वो चोट बाद में निकल के आती है बाहर, दर्द होता है, गंदा दर्द होता है, स्नो से छिल जाती हैं चीजें, है ना? So one of us, he suggested that we have to use a rubber shoes with rubber soles क्योंकि उनकी grip बहुत अच्छी है. So we were not having rubber shoes, so we rented shoes for 100-200 rupees per pair of shoes. राइट अगर हम वो नहीं करते एंड दे वर बूट्स लाइक उन्होंने आपके पैर में नीज के नीचे तक का थोड़ा सा स्पेस कवर किया हुआ था, सो वी वर एबल टू वॉक इजीली. सिमिलर सेम थिंग बिकॉज ही न्यू दैट वी आर गोइंग टू फेस डिफिकल्टी, सो he measured the disturbance that okay the season it seems like there will be a lot of snow, right? If there will be a lot of snow, we are going to face this difficulty. So before my friends, my guys, my colleagues, right, my buddies, they are going to feel the impact, let me take a corrective action. We'll go to the shop, buy the rubber sole shoes or rent the rubber sole shoes, and then everything will be fine again. This is called preventive measure. This is called what क्या कहते हैं इसको? This is called anticipatory control, right? This is called taking the corrective action beforehand. मैं मतलब अगर suppose मैं normal shoes में चला जाता, normal shoes के साथ क्या problem होती है? It's not high ankle kind of shoes. The snow will enter your shoes. Once snow will enter your shoes, it will melt and your feet will be wet all the time. When your feet are wet all the time, you never feel comfortable. Right? So there are various, so if the person is experienced, she is going to take corrective action beforehand always. In real life, taking corrective action beforehand is always good. Okay? And in control also the same theory applies. But there is a problem. What is the problem? When there is a change in load, the controller will take, okay, beforehand. Right? Now, how the controller will know? How the controller will know that how much the disturbance is going to affect? So write down sixth point. Sixth point. But there is a problem. But there is a problem with feed forward controllers. और before that एक point और लिखते हैं theoretically. So far theoretically, if you see the theoretical possibilities only, there is a possibility that we can achieve perfect control in case of feed forward control strategy. Theoretically, yes or no? Yes, because अगर आपका process अपनी जैसे see this the process was going like that, the disturbance is coming, but before the disturbance can affect the process, you take corrective action and the process is still going on, right? What is the logic of feedback? The process was going like this, it was disturbed, and then you took action, it came back to you, right? So ideally speaking, you can never achieve perfect control. Theoretically speaking, you can never achieve perfect control in feedback control strategy, right? क्योंकि feedback का तो फंडा ही है कि जब बिगड़ेगा उसके बाद सुधारूंगा. फीडबैक का फंडा क्या है? ये पहले डेविएट करेगा, उसके बाद करेक्टिव एक्शन होगा. तो डेविएट तो कर गया ना, so there is no 100 perfect control in feedback control strategy. So theoretically also feedback में there is no possibility, because feedback की थ्योरी ये कहती है कि जब अपने सेट पॉइंट से डेविएट करेगा तभी एक्शन होगा. So theoretically there is no possibility. Theoretically there is no possibility of perfect control. What is the meaning of perfect control? I'll write down that also. Theoretically there is no possibility of perfect control in feedback control strategy. In feedback control strategy, while while theoretically only there is a possibility, at least theoretically there is, है ना. अगर आपका प्रोसेस डेविएट, क्योंकि डिस्टर्बेंस को तो आपने मेजर कर लिया, आपने जब डिस्टर्बेंस को मेजर कर लिया और नाउ यू ऑलरेडी हैव द कंट्रोलर में वो कैलकुलेशन फिट है कि ये डिस्टर्बेंस इसको कितना इफेक्ट डाल सकता है, तो आपने उसके एंटी, है ना, उसके ऑपोजिट वाला इफेक्ट क्रिएट कर दिया कि नेट इफेक्ट जीरो हो जाए और डिस्टर्बेंस आपका जो स्टडी स्टेट है मेंटेन रहे, है ना. सो थ्योरेटिकली स्पीकिंग देयर इज नो पॉसिबिलिटी ऑफ परफेक्ट कंट्रोल इन फीडबैक कंट्रोल स्ट्रेटजी, while there is possibility of perfect control in feed forward control strategy, so theoretically there is possibility. Now there is a problem here. That was the 6th point. 7वां पॉइंट लिखिए. ये पॉइंट्स में पढ़ाने में इसलिए अच्छा लगता है क्योंकि ये जो टॉपिक्स हैं, they are small topics. Normally when you read this topic, you don't know what to read, what to leave, है ना. So I have collected these points in this format only. We will complete this topic. Seventh is, but in reality there is a problem. Reality means practically there is a problem with the feed forward control strategy. But in reality there is a problem. There is a disadvantage associated with. आप बोलोगे सर डिसएडवांटेज क्या होता है? अगर आप किसी चीज के बिगड़ने से पहले ही एक्शन ले लो तो ऑफ कोर्स इट इज ऑलवेज गुड. यस, इट इज गुड, बट देयर इज अ प्रॉब्लम, देयर इज अ डिसएडवांटेज विद फीड फॉरवर्ड कंट्रोल स्ट्रेटजी. फीड फॉरवर्ड कंट्रोल स्ट्रेटजी. क्या डिसएडवांटेज हो सकता है? देखो, फीड फॉरवर्ड कंट्रोल स्ट्रेटजी डिसएडवांटेज देखो क्या है. यू नो दैट वी आर मेजरिंग द डिस्टर्बेंस एंड वी आर टेकिंग करेक्टिव एक्शन. इस बीच में देयर इज अ कैलकुलेशन, two calculations are there. One calculation that how much the process is going to affect the how much the disturbance is going to affect the process. How this calculation will be done? Who is going to do this calculation? The controller. कि अगर disturbance में change हुआ तो वो process को कितना impact करेगा? How this is going to be done? This will be done by the coding, by the program, by the algorithm which is fed into the controller. तो controller को मैंने algorithm तो दे दी, पर क्या वो algorithm 100% correct है? One decision that how much impact the control this change in disturbance will be having on the process. This calculation is done by the controller, and this depends that how accurate is your process model between the disturbance and the process. One more calculation will be done by the controller, that how much I should change the manipulated variable that it cancels out the impact of disturbance. So there should be one more model between the manipulated variable and the process. So what I want to say, that if any one of this model is not perfect, is not correct, your corrective action won't be perfect. और आप corrective action ले तो लोगे, but आपका process थोड़ा बहुत deviate कर जाएगा. Means what is the disadvantage? Your modeling should be perfect to achieve perfect control. Otherwise you won't achieve perfect control. थोड़ा सा deviation होगा. Right? Means what is the first point? That the process model should be 100% accurate. Should be 100% accurate. क्या 100% accurate नहीं होगा तो कंट्रोल नहीं होगा? कंट्रोल तो होगा, परफेक्ट कंट्रोल नहीं होगा. Your process model should be 100% accurate to have perfect control. To have perfect control. Perfect control. ठीक है. अगर आप 100% accurate मॉडल नहीं बनाओगे, मॉडल मतलब क्या होता है? मॉडल मीन्स हाउ द डिस्टर्बेंस इज अफेक्टिंग द प्रोसेस, हाउ द मैनिपुलेटेड वेरिएबल इज अफेक्टिंग द प्रोसेस. मॉडल, ये वही मॉडल है भाई जो पहले कर रहे थे. हाउ डिस्टर्बेंस इज अफेक्टिंग द प्रोसेस, वन मॉडल. हाउ मैनिपुलेटेड वेरिएबल इज अफेक्टिंग द प्रोसेस, सेकंड मॉडल. दीज टू मॉडल शुड बी 100% accurate. दैट इज द प्रॉब्लम. अगर ये accurate नहीं होंगे, then your action won't be perfect, right? And what do you think? Models जो हम बनाते हैं 100% accurate हो सकते हैं क्या in reality? No, models are full of assumptions. So, but since a lot of assumptions are there, we can't have 100% accurate model. We can't have 100% accurate model, and hence can't have perfect control and hence can't have perfect control. Correct? It means अच्छा तो है बट कर नहीं सकते. फीड फॉरवर्ड इज बेटर बट वी कांट अचीव परफेक्ट कंट्रोल. तो परफेक्ट कंट्रोल अगर नहीं अचीव कर सकते तो फीडबैक ही यूज कर लो ना. फीडबैक में वैसे भी परफेक्ट कंट्रोल नहीं हो रहा था. बट देयर इज वन मोर डिसएडवांटेज आई विल टेल यू, ड्यू टू विच फीड फॉरवर्ड कंट्रोल बेटर तो है बट यूज नहीं करते, चले जाते वापस फीडबैक की ओर. Why? Okay, you got this point, right? That we can't make 100% accurate model, right? I can't make 100% accurate model. So my controller will calculate that this disturbance is going to affect the steady state by this much. That calculation will be wrong. And similarly, my controller will calculate that I should change the manipulated variable by this much to cancel out the disturbance. That calculation will also be wrong. So ultimately आपका जो process होगा वो steady state से थोड़ा बहुत इधर उधर भटक जाएगा and you won't be having perfect control. So that is why anticipation is good, but we can't achieve perfect control because the process model is never 100% accurate. So there is a line here. There is a line जो गेट में भी पूछी जा सकती है, पूछी जा चुकी है. In fact, there is a line that feed forward. I'm writing in short. Okay, feed forward control strategy is sensitive to modeling errors. चलेगा? What does it mean? Sensitive to modeling errors. क्या मतलब इसका समझो? फीड फॉरवर्ड कंट्रोल स्ट्रेटजी इज सेंसिटिव टू मॉडलिंग एरर्स. मींस सेंसिटिव का मतलब कि अगर आपकी मॉडलिंग में एरर हुई तो आपका कंट्रोल बेकार होगा. ऐसा है कि नहीं है? तो दिस स्टेटमेंट इज ट्रू. ये क्वेश्चन है. इनसेंसिटिव, देखो क्वेश्चन जब करना ध्यान रखना, इनसेंसिटिव और सेंसिटिव, दैट इज इंपॉर्टेंट. फीड फॉरवर्ड कंट्रोल स्ट्रेटजी सेंसिटिव टू मॉडलिंग एरर्स मींस सेंसिटिव. अगर मॉडलिंग एरर हुई तो आपका कंट्रोल जितनी ज्यादा द मोर द मॉडलिंग एरर द वर्स इज द कंट्रोल. इन केस ऑफ दिस, in case of feed forward control. So there is one more problem. Do you know that what are the possible disturbances for a system? Not always. There can be. It is required, in this case, in feed forward, it is required to have knowledge of all the possible, क्योंकि आपको मेजर किसको करना है? डिस्टर्बेंस को तो मेजर करना है और पता ही नहीं कि अच्छा ये भी डिस्टर्बेंस था, चलो इसको भी मेजर करते हैं. तो सारे डिस्टर्बेंसेस, मतलब कुल मिला के बात वही, आपको प्रोसेस की नॉलेज बहुत अच्छी होनी जरूरी है. इट इज रिक्वायर्ड टू हैव नॉलेज ऑफ ऑल द डिस्टर्बेंस, ऑल द पॉसिबल डिस्टर्बेंसेस. क्या फीडबैक में ऐसा था? नहीं, फीडबैक में ऐसा नहीं था. दिस इज वन एडवांटेज ऑफ फीडबैक. ऑल द पॉसिबल डिस्टर्बेंसेस, विच इज अगेन नॉट possible disturbances, क्योंकि आपको मेजर ही उसको करना है. नाउ व्हाट वाज द एडवांटेज ऑफ फीडबैक? देयर इज वन एडवांटेज ऑफ फीडबैक ओवर फीड फॉरवर्ड, दैट इन फीडबैक you measure the control variable. Whatever be the disturbance, it is impacting control variable, then action will be taken. So ultimately आपको क्या पता लगा? That ultimately you know that feed forward is better, but because you can't have 100% accurate model, so you are again going back to feedback control. Okay, so it is required to have knowledge of all the possible disturbances. Knowledge of all the possible disturbances, which is again not possible in practical situation. Which is not possible again, है ना? If this is possible, then yes, theoretically speaking, you can have 100% control. Now the question is, I'm always using perfect control. What is the meaning of perfect control? Simple. Perfect control, it's not a new definition which is only there in feed forward. Perfect control means your control variable should not deviate, not even for a single second. Your control variable should not deviate means there should be set point tracking. बोलो क्या सर ये कोई नई बात है? क्या हमने पहले नहीं पढ़ा है? देखते हैं. And there should be disturbance rejection. क्या ये नई बात है? Actually होता क्या है? That these two things normally we discuss, these two names we normally discuss in feed forward only. So students think that okay, this is something special to feed forward controller only. But क्या आप पहले नहीं पढ़ो? What is the meaning of set point tracking? As the set point goes, your controller आप मतलब control variable set point के पीछे पीछे चलता रहे. That is called set point tracking. What is the meaning of disturbance rejection? Disturbance rejection means to reject the effect of disturbance. क्या हमने पहले नहीं पढ़ा है? Yes, this was our objective in feedback also. यही तो objective था यार. Feedback में क्या objective था? What was your objective in feedback? If you change the set point, your process variable should exactly follow the set point. This was my objective. If there is a disturbance, your controller should be able to reject means, or you can say your controller should be able to correct whatever effect of disturbance was there. So ऐसा नहीं कि कोई नई बात है, right? Ultimately, for a perfect control, what we want that there should be set point tracking, and we want that there should be disturbance rejection. Right. So suppose if your control variable y bar is some function of YSPS. Okay, let us call this function as GSPS, and your control variable is some function of not GSPS. Let us some function of YSPS, right, and some function of D bar S, right? ऐसा ही होता है, पहले भी यही पढ़ा हुआ है. Okay, this is some function and this is function. Of course, for set point tracking, we know that what is the meaning of perfect control? Y bar should always be equal to your YSP, right? Y should be always equal to set point. Means this coefficient should be equal to 1 and there should be no effect of disturbance. Disturbance change hota rahe, there should be no effect. So this coefficient should be equal to 0. So for perfect control, this should be equal to 1. This coefficient, ये अभी आगे apply कर देंगे. This coefficient should be equal to 1. Should be equal to 1. And this coefficient should be equal to 0. This coefficient should be equal to 0. Okay. Disturbance rejection, set point tracking. Okay. Not a new thing. ये पहले भी करते आ रहे हैं. Now, let us make a feed forward control block diagram. Not very typical. आप बड़े आराम से बना सकते हो. But let me tell you that this is a feed forward, a totally new kind of control strategy. So whatever shortcut method we have learned means क्या बताया था आपको, forward path divided by 1 plus open loop transfer function, that is not valid. But again, the basics of block diagram are valid here. ठीक है. So what is the control, this diagram for this feed forward control? You can see here, normally suppose this is a process, right? Suppose this is a process, the process having the transfer function GPS. This GPS, just like the feedback, but there are some minor differences. We have this disturbance here. ऐसा ही था, है ना? In feedback also the same transfer function, the same kind of things were there. This is the load U, L, D, whatever you want to write, D bar S. And this is my variable which I want to control. Suppose let me write this as Y or Y bar. Okay. Now, what we do normally, we normally measure this. और यहाँ पे यही नहीं करना है, आपको control variable को measure नहीं करना. What we are going to measure is the disturbance. So this is the disturbance, right? I'm going to measure the disturbance. So I was talking about that I should have the perfect knowledge of the process. Means I should know how disturbance is affecting the process and how manipulated is affecting the process. So this GD and GP should be perfectly known. Okay, so GD, I'm measuring the disturbance. Now, of course, if I'm doing some measurement, then this measurement should go to what? Should go to the, first of all, there should be a measuring element. This measuring element is going to measure the disturbance and then it should be compared with the set point. So, of course, the basic structure is same. My measurement is being compared with the set point, but this measurement is not for the control, this control variable. This measurement is for the disturbance. Okay, let me make some space here. I'll make this diagram here only. So, this is my GM, means the measuring element. Now, this measurement is going to be compared with, so if it is going to be compared, there must be a comparator and with a negative sign. So there are a lot of similarities also in feedback control and in feed forward control. There are a lot of similarities. Ki my measurement is being compared with a set point. Okay, so this will be the set point. So you can have YSP here. This set point YSP bar S goes to a block which is GSP. Again, GSP was there. GSP, right, with a positive sign. It is going to be compared, or जब भी compare होगा the set point and the measurement, we know that there has to be some error. This is the error function. This error function should go to what? Of course, it should go to the controller, and this is my feed forward controller, FFC. right? This is feed forward controller. Now the controller output goes to what? The controller output always goes to the final control element or the GF or the GV, right? So it should go to the final control element. Let me make here GF or GV, and it is this manipulated variable affects the process. This relation GP का मतलब क्या हुआ? How manipulated variable affects the process. How disturbance affects the process. How manipulated variable affects the controlled variable. How disturbance affects the controlled variable. How disturbance affects the controlled variable GD. How manipulated variable affects the controlled variable GP. समझ आ रहा है कुछ कुछ? And this is how. See, what is the difference? What are the similarities? My measurement is compared with set point. Then error goes to controller. Controller talks to the gives instruction to the final control element. So this is basically the process. This is my process. Okay, and this is my controller. This entire part is controller. Fine. Now the question is, what is the transfer function of this controller to have perfect control? Suppose if model is known to 100% accuracy. मान लेते theoretically I'll always assume that model is completely known. So what should be the transfer function of this controller FFC to have perfect control? Practically, you can't have perfect control because you cannot understand the process to 100% accuracy. For achieving, first of all, block diagram है. Block diagram को देखते ही आपको क्या करना है? We have to reduce the block diagram. From where to start? You can start from here, not a problem. Y is equal to what is here? DGD. So DGD. I'm not writing S. S को मैं omit कर रहा हूँ. Y is equal to DGD plus what is this? D. What is this? DGM. What is this? YSP, GSP. So this is DGD plus what is coming from here. So यहाँ से शुरू करते हैं. This is also D, DGM, YSP, GSP minus DGM becomes error, right? So YSP bar GSP, YSP, GSP minus DGM minus D bar GM. This is becoming error. And then this is getting multiplied to the controller. Let us say that the feed forward controller is having the transfer function GC. तो किससे multiply हो जाएगा? GC से, then it is multiplied by GF, and then it is multiplied by GP. Now I am here. This is added to DGD to give Y. बन गया block diagram, बड़ी आसानी से solve हो गया. Now let me also tell you that it's not like that. This is always the one possible diagram of feed forward controller. If in GATE exam there is a question on feed forward control and they have not provided you any diagram, then you can consider this as a diagram. But in question, if they have provided you some diagram, then solve the diagram, reduce the block diagram to have this kind of relation. Now you can always write this as Y bar is equal to, this is D bar, right? So you can take D bar common, and this will be GD minus GM, GC, GF, GP, correct? Plus YSP, and YSP में क्या क्या आ जाएगा? GSP, GC, GF, GP. This is the reduced block diagram. Now, what should be the, for perfect control, we have two criterias. First one is set point tracking. Actually, for perfect control, आप जो set point दोगे वही यही होना चाहिए, है ना? यही तो एक बात है. Y should be equal to YSP. And when Y should be equal to YSP, then when this is equal to 0 and this is equal to 1. So इसको बस इन्होंने दो पार्ट्स में बांट दिया. इसका कोई अलग से स्पेशल मतलब नहीं है. Set point tracking. So set point tracking means the coefficient of set point should always be equal to 1, so that Y should be equal to YSP, and disturbance rejection means the coefficient of D bar should be always equal to 0. So set point tracking gives you that this coefficient GSP, GC, GF, GP should be equal to 1, and disturbance rejection gives you what? It says that this must be equal to 0. So GD minus GM, GC, GF, GP equal to 0. So from here we get GC means the controller transfer function is equal to GD divided by GM, GF, GP. That is the transfer function of a feed forward controller for perfect control. राइट ये कंट्रोलर का ट्रांसफर फंक्शन है. ऑफ कोर्स अगर आपको जीडी की परफेक्ट नॉलेज नहीं है, जीपी की परफेक्ट नॉलेज नहीं है, तो कंट्रोलर भी परफेक्ट नहीं बनेगा, है ना. सो नॉर्मली दिस ऑल्सो हैपेंस दैट मोस्ट ऑफ द प्रॉब्लम्स जीएम एंड जीएफ इज इक्वल टू 1. इन दैट केस इट शुड बी जीडी बाय जीपी. गेट में क्वेश्चन है, उसमें बच्चे बहुत परेशान होते हैं कि सर जीडी बाय जीपी होता है कि माइनस जीडी बाय जीपी होता है. देखो अकॉर्डिंग टू दिस डायग्राम इट इज जीडी बाय जीपी. अप्लाई कॉमन लॉजिक ना, उस प्रॉब्लम में ऑल द ट्रांसफर फंक्शंस आर हैविंग माइनस साइन, so minus GD by GP. Because why minus GD by GP? Because this block diagram can be slightly different. There can be positive feedback. There in this case also there can be positive feedback or something else. Who knows? In that question the block diagram is not given. That's why I'm telling you. कॉमन लॉजिक लगाया करो ना, फालतू में परेशान हो जाते हो. सर आपने जीडी बाय जीपी बताया था, अब यहाँ पे माइनस जीडी बाय जीपी कहाँ से आ गया, मतलब हमने नहीं पढ़ा, मतलब हमें नहीं आता, मतलब ऐसा कुछ नहीं है. It totally depends. हो सकता है for that problem there's a different block diagram. So if block diagram is not given, right, and you are finding something, then it should be GD by GP. But suppose the options, all of the options are having minus GD by GP, तो कर लो minus GD by GP, उसमें कोई दिक्कत वाली बात नहीं है, ठीक है. So the controller should have this transfer function. Now if you put this transfer function here in GC, then you will be having put करते हैं, देखते हैं, GSP into GD by GM GF GP into GP. ठीक है, क्या क्या आ गया यहां से, इज इक्वल टू 1. सो व्हाट इज गेटिंग कैंसिल्ड, GP इज गेटिंग कैंसिल्ड और कुछ नहीं. GD by GM GF, GM is 1, GF is 1. So yeah, so it is GSP is equal to GSP is equal to GM into GF divided by GD, and if GM GF is equal to 1, so GSP is equal to 1 by GD, right? GF is also there. What is GSP is 1 by GC GF GP, right? GC, acha, there was GSP into GC, there is GF also, there is GF also, so GF will be getting cancelled, GF won't be there, so GM by GD, right? If GM is 1, then 1 by GD. तो आप बोलो सर क्या इनको याद रखना है, इनको याद रख सकते हो. These two formulas, these two expressions you can remember, okay? And yes, as I told you that if transfer functions are not, if diagram is not given, then you can use this. But there is one problem in gate. मैं अभी से बता रहा हूँ कि इस गेट की प्रॉब्लम में माइनस GM by GD, minus GD by GP करने से आंसर GM GF is equal to 1, and minus GD by GP is giving you the options. So I cleared one doubt that if in case the block diagram is not given and they're asking you that what is GSP or what is GC, so can you apply this formula as it is? Yes, you can. But suppose if block diagram is given, like there was a question in 2014, there was a block diagram. In that block diagram also, if you apply the same formula, the answer is coming. But what I suggest that if block diagram is given, do this. Apply set point tracking, apply disturbance rejection, and the problem is solved. And there is one problem where I told you the problem is कि सर यहाँ तो minus GD by GP दिया है आपने, GC आपने GD by GP बताया, यहाँ पे minus GD by GP दिया है. तो अगर minus GD by GP से आंसर आ रहा है तो minus GD by GP कर लो. It is possible that the block diagram is not same as before. In that case, you will be getting the answer as minus GD by GP. Right? There can be some block diagram with respect to which the answer will, the GC will be minus GD by GP. तो इतना नहीं सोचते हैं उसमें, ठीक है. आंसर किया, सोच लिया कि ठीक है यहाँ कोई और डिफरेंट ब्लॉक डायग्राम रहा होगा, आगे बढ़ गए, ठीक है. आप लोग का क्या आदत है, आप लोग फालतू चीजों में ज्यादा ध्यान लगा देते हो और इधर जो पढ़ना है, जो चीज समझनी है, वो इधर उधर रह जाते हैं, ठीक है. ओके, सो वन मोर थिंग आई वुड लाइक टू एक्सप्लेन हियर दैट ओके आई टोल्ड यू दैट आई शुड नो दैट द कंट्रोलर शुड हैव the transfer function of the controller should be designed like that so that it can take the corrective action. अब अगर आप इस ट्रांसफर फंक्शन का कंट्रोलर यूज करोगे तो कंट्रोलर अकॉर्डिंग टू चेंज इन डिस्टर्बेंस, उसके पास ये इंफॉर्मेशन भी है, सारी इंफॉर्मेशन है. इट कैन चेंज द मैनिपुलेटेड वेरिएबल सो दैट मैनिपुलेटेड वेरिएबल विल अफेक्ट द प्रोसेस इन सच अ वे दैट द इफेक्ट ऑफ डिस्टर्बेंस विल बी कैंसल्ड बिफोर द इंपैक्ट ऑफ डिस्टर्बेंस इज फेल्ट बाय द प्रोसेस. डिस्टर्बेंस को पहले से ही पता है कि इतना नुकसान होना है तो मुझे इतना एक्शन लेना है. लेकिन ये जो मॉडल है, ये मॉडल, दिस मॉडल GD and GP is not 100% accurate, so the controller transfer function won't be accurate and the action of the controller won't be accurate. Now you may ask कि सर ये क्या है, Why GSP is there? GC तो design करना था. Why you are finding GSP? The thing is, in process dynamic, in feed forward control action, let me give you a small example. मैं अलग से नहीं बना रहा, यहीं पे बना दे रहा हूँ. Suppose you have a liquid level control system. So what you are going to control? In liquid level, what you are going to control? And what you are going to measure? See, this is the liquid level control system. You have a valve. ये डायग्राम कई बार बना चुके हैं आप, थोड़ा बड़ा सा डायग्राम बना लो. सपोज दिस इज द सिचुएशन. व्हाट इज द कंट्रोल्ड वेरिएबल? द कंट्रोल्ड वेरिएबल इज लिक्विड लेवल. आप हाइट को कंट्रोल करना चाहते हैं. H इज द कंट्रोल्ड वेरिएबल. इफ आई एम गोइंग टू अप्लाई दिस फीड फॉरवर्ड कंट्रोल, सो कैन आई मेजर H? नो, इन दैट केस आई कैन नॉट मेजर H. सो व्हाट आई एम गोइंग टू मेजर? आई एम गोइंग टू मेजर द disturbance. What will be disturbance? This. You know that inlet flow rate is the disturbance. So I am going to measure the disturbance, right, with the help of some measuring element, and this will be sent to the comparator and then to the controller. Suppose I am sending this to the okay, I am sending this information to the controller. But the thing is, this is the feed forward controller. Okay, and to the feed forward controller, I will also provide the set point of this height, and let's say, so to this feed forward controller, I am going to provide set point of what? HSS, correct? This HSS is the set point given to the feed forward controller. Now the measurement which is taking, we are taking the measurement of this inlet flow rate. Iski unit kya hai? The inlet flow rate is having the unit of meter cube per minute, suppose, right? And HSS is in meters, not minutes, meters. So can I compare this meters to meter cube per minute? Of course not. So there has to be a conversion. तो वो conversion कहाँ से आएगा? That is the conversion GSP. This GSP model will be there. This GSP model will be there, and then it will be going to the feed forward controller. And then feed forward controller, model of the feed forward controller I gave you. This feed forward controller manipulates the manipulated variable. Right? This is a small diagram for feedback feed forward control. क्योंकि बच्चे के बार पूछते हैं सर आपने कहा कि कंट्रोलर डिजाइन करना था, वो आपने GSP क्या लिख दिया? Why GSP should be there? Right? So this is because this is the measurement and this is the set point. Can I compare one type of quantity with different type of quantity? ये फंडा है ना. तो यहाँ एक GSP होना चाहिए. And of course this GSP is okay, this is going to this comparator. ये GSP बताया ना, this GSP going to the comparator. वो comparator को मैंने कंट्रोलर के अंदर काउंट कर लिया है, right? And then we are giving set point to this controller, and this is the measured value. Then they are compared, and then the final control element takes the action. Fine. This is feed forward control. Now you may ask, sir, suppose if this quantity and this quantity, I mean the measurement which we are taking and the set point which we are giving, if they are same quantities, similar quantities, then possibly GSP will be 1. Yes, in that case GSP will be 1. Okay. So, right, one more thing, suppose this GSP model is also going to, this is also going to calculate that for this much change in inlet flow rate, how much change will be there in the height, right? And accordingly, this height will be compared with the set point which I am giving. Right? So this GSP must be there to convert this flow rate into corresponding height. तो flow rate को height में कैसे बदलेंगे? Again, equations of mass balance, equation of energy balance won't be required. Equation of mass balance will be there. So this is why GSP is also found. So for set point tracking, we are finding GSP from there, and from disturbance rejection, we are finding GC. If you know the process to very much accuracy, then of course the controller, the feed forward controller won't let your control variable to deviate, and in that case you can have perfect control. But I told you what is the problem. Okay, I told you what is the problem. See, there is one more disadvantage. Suppose you are not able to model the process accurately, right? Suppose the modeling of the process, the GSP or the GC is not accurate, right? Suppose I am giving the set point of 5 meters, okay? But this modeling is not accurate, this GSP is not accurate, okay? In fact, this is measurement, okay, I made a mistake here, please correct it. That's what I was, because this should be, either you can place this here or here, right? So this should not be placed in the, okay, please correct this, I'll make this one again. This should not be placed in the path of this measurement. It should be placed in the path of set point, right? So please correct that diagram. Due to lack of space, I made this mistake here. You should not follow that diagram. This is my disturbance and I'm measuring this one, right? I'm measuring this one and comparing this. This is my controller, FFC. I'm comparing this. Now, of course, from here, I'm getting a flow rate in meter cube per minute, suppose, right? And we have some HSS. Suppose SSS is equal to 5 meter. Of course, I can't compare these two values. So there has to be GSP. So GSP, देखो GSP किसके साथ में है? Set point के साथ में ना? So I have GSP here. So I place the GSP here before this controller, and then the controller takes action. So please do this correction. So I was feeling like there is some mistake, but I was not able to find that what is the mistake. So this corrects, this manipulates the outlet flow rate accordingly according to the change in this disturbance, right? So this model must be known. But I was talking about a case that suppose the modeling is not accurate. So if the set point is 5 meter and the exact height corresponding to 5 meter, the exact flow rate is something else. But this modeling is not accurate. So the flow rate को convert करेगा, that also won't be accurate. Now controller do not know what is accurate model, what is inaccurate model. Controller just follows the set point given by this GSP. Suppose according to a 100% accurate model, the GSP should give a set point of 10 meter cube per minute, right? But it is giving 8 meter cube per minute. So controller will do the things according to 8 meter cube per minute. So ultimately होगा क्या? Ultimately the process will settle such that error will be permanent. See, देखो controller कब काम करता है? Controller तब काम करता है जब controller feels that there is error. In this case, controller won't feel that there is any error. Why? Because controller is getting a set point of 8 meter cube per minute, right? Controller is getting a set point of 8 meter cube per minute. But you know, with respect to the process, there will be error always. So in feed forward control strategy, there is a possibility of permanent error in the system, which is not there in feedback control. One disadvantage. ठीक है, ये disadvantage आपको कहीं लिखी हुई नहीं मिलेगी, ये लॉजिक से आप सोच सकते हो, ये बेसिक लॉजिक से सोच सकते हो. That because the feed for देखो in feedback control आप बोलो सर feedback में भी तो ऐसा हो सकता है. Feedback में मॉडल की जरूरत ही नहीं, because in feedback we are measuring the controlled variable itself. So अगर in feedback, suppose if measurement is saying that control variable is 6 and we want it to be 5, so definitely there is some error, the controller will work and bring it to 5. But here suppose we are not measuring control variable, we are measuring disturbance, right? And we have this model here, right? Now if this model is inaccurate, then this conversion also will be inaccurate. So the set point going to the controller will be inaccurate. It was the same as the case of the PI controller with the non-unity feedback system. उसमें भी यही हुआ था. Right? So this is all about, and you can have various cases where feed forward control can be used, can be beneficial, right? And again, the same thing I would like to say. You can ask, sir, feed forward कब use करेंगे? Again, the same thing. If feed back control is not satisfactory, you can go with feed forward control. You may ask, sir, in which case feed forward will be most suitable? Suppose you have a lot of time lag in the process. Then what happens? या कई बार से लोग कई सारे capacities series में connected हैं. Suppose a lot of capacities are connected in series, right? When there will be disturbance, right? आपका control action कब आपका जो control जो feedback control है, when it is going to take action, when it will see that the control variable is getting deviated, right? But there is a lot of time lag in between. Suppose the last tank is your control variable. So when the control variable gets deviated, before that, all the previous tank will get deviated, and the problem will remain in the system for a long period of time. After that, this controller will take action. So in that case, feed forward control can be more beneficial, right? But I told you that what are the problems associated with the feedback control. The modeling must be very much accurate. ठीक है, इस पे theoretical question कई बार आ चुके हैं, and there has been a lot of problems in GATE regarding these two. So आप इसको देख लो. And this was all about this feed forward control strategy and cascade control strategy, and that makes the discussion on advanced control strategy complete. Now you will also find I'll attach one sheet of measuring elements so that you can solve all the problems of match the column and process dynamics and control, right? And this is complete discussion of the subject of process dynamics control. I hope you have enjoyed the lectures, and I have tried my best to cover each and every portion to the required depth. Jitne depth mein jana hai utna cover kiya hai. Yes, one point I would like to mention that the new topics that has been added, I should not take topics, it is only one topic, right? So we are currently planning to launch lectures of all the new topics in a combined way. I mean, all of them at once, so that the other students also get benefit of that. So that will be done, don't worry. But this is the major portion, 98-99% portion of the course, except that. So that will be covered. आप इस यहाँ तक जितना किए आप इन सारी चीज़ों को कर लो. यहाँ तक करने के बाद यू आर इन अ पोजिशन टू सॉल्व ईच एंड एवरी प्रॉब्लम. आई टोल्ड यू दैट कि जो शीट है वो मैंने अटैच कर दी है लेक्चर्स के लास्ट में. आपको शीट भी मिल जाएगी. यू कैन नोट डाउन द नेम. डोंट रन बिहाइंड ईच एंड एवरी नेम्स, राइट? जस्ट हैव अ लुक on the table before the examination. You can have a look on the table after in 1 month, in 2 months you can have a look on the table. The most important names of the instruments you must know. Okay, now also let me tell you that there are some question in process dynamics and control which are based on instruments. इसका ये मतलब नहीं है now you have to go through each and every. What we had to discuss was control valve, and I have discussed the control valve in very much details. Now it does not mean that you go through the construction of bimetallic thermometer, you go through the construction of thermometers, or you go through the construction of other measuring instruments. कुछ नहीं करना है ऐसा. But you'll say कि sir there are some question in GATE exam. All those questions will be solved by basic common logic. है ना? हम डिस्कस कर लेंगे उन क्वेश्चंस को इन केस इफ यू आर हैविंग एनी डाउट, एंड यू विल फाइंड दैट इट इज नॉट रिक्वायर्ड टू गो थ्रू द कंस्ट्रक्शन और वर्किंग प्रिंसिपल ऑफ ऑल दोस इंस्ट्रूमेंट्स, राइट? स्टिल when you're solving the problem, there are certain informative questions. Like suppose in recent years there was a question that thermocouple works on what principle, so it was Seebeck effect, right? These kind of questions, इनको करने के लिए क्या strategy होनी चाहिए? When you are solving the problems, okay, this was the question, I learn it, that's all. You can go through the Seebeck effect also, Peltier effect, but that is not very much in deep. आप एक बार 2-3 लाइन की चीजें पढ़ सकते हैं, right? Suppose in the upcoming examination, suppose they are asking about totally brand new kind of instruments, then you will be in the same situation like the other students, nothing to be worried, right? So this was all about from our side, from engineers in process dynamics and control. I hope you will be able to solve majority of the problems, at least in the first round. आप जितने क्वेश्चन सॉल्व करोगे उसमें से 70-80% क्वेश्चन आप सॉल्व कर लोगे. I know there are some typical problems where you are going to face difficulties. Okay, in that case, definitely you can discuss it with me.